कि आप ये संविधान हम बदलने वाले हैं और सारा कायदा कानून बदल देंगे, ये फेक नैरेटिव आपने सेट किया। हेल्थ इंश्योरेंस, अरे जब आप मुख्यमंत्री थे, आप बोल रहे 25 लाख हाँ आप देंगे। जब आप मुख्यमंत्री थे तो जो सीएम मेडिकल रिलीफ फंड है वो आपने 2 करोड़ के ऊपर खर्चा नहीं किया, ये 25 लाख कहाँ से लाएंगे? तो ये सारा ये सब झूठी बातें हैं, इसको कोई सीरियसली लेने वाला नहीं है। फ्री मेडिसिन की आप बात करते हो, आपको मौका था, आप कोरोना के समय आप मुख्यमंत्री थे, तब आप क्या किया? जो बॉडी बैग्स जो 500-600 की मिलती थी आपने 6000 में बेची, तो बॉडी बैग्स क्यों नहीं आपने फ्री में दी? जब आपकी सरकार ही नहीं आएगी, अगर नहीं आने वाली सरकार को आप बोल रहे हैं कि हम 25 लाख का लिमिट करेंगे हेल्थ इंश्योरेंस का, तो जब आपके हाथ में था लोगों को कुछ फ्री देने का, तब तो आपने दिया नहीं, सिर्फ लेने का काम किया। ठीक है, वो भी हम इसको मद्देनजर करते हैं, हटा डालते। दूसरा 4000 अनएम्प्लॉयड देंगे यूथ को, 4000 पर मंथ, इसका भी कोई आपके पास कोई प्रावधान नहीं है, तो सिर्फ बोलने की बात है, जैसा ताजमहल दे देंगे वैसे दे देंगे। तो इस प्रकार की ये सारी बातें। दूसरा, जो वर्षा गायकवाड़ महाराष्ट्र से चुनी हुई कांग्रेस की खासदार, हम महाराष्ट्र में कोई भी पॉलिटिकल, अगर हम सरकार की शुरुआत भी करते, पहला दिन जब सरकार का जो विधिमंडल का पहला दिन होता है, हम छत्रपति शिवाजी महाराज के वहां पर जाकर माथा टेक कर हम सरकार चलाते हैं, उनके विचारों की सरकार है। आप एक महिला, आप एक कांग्रेस की आप खासदार है, महाराष्ट्र से चुनी है, आप कोई पाकिस्तान की नहीं है, और वहां आप छत्रपति शिवाजी महाराज का की प्रतिमा कोई आपको दे रहा था, शायद आपको शरद पवार जी को देनी थी, और आप फोटो निकालने में इतनी व्यस्त हो गई कि आपको छत्रपति शिवाजी महाराज की जो प्रतिमा थी उसको हटा दिया, अपने हाथ से उस कार्यकर्ता को रोका और अवमान किया। और आप जब मालवण में छत्रपति शिवाजी महाराज का पुतला जो एक एक्सीडेंटल था, उसको आपने इतना बड़ा किया, और आप कह रहे कि हर एक जिले में आप छत्रपति शिवाजी महाराज का एक मंदिर बनाएंगे, मगर आपके जो खासदार आमदार है, छत्रपति शिवाजी महाराज ने हमेशा महिलाओं को मान सम्मान की सीख दी, और उनके राज्य में जो महिलाओं का अपमान करते थे उसका क्या असर होता था आपने देखा है। कड़ी से कड़ी सजा महाराज उनको देते थे। तो आप ये जो 3 लोग हैं, अरविंद सावंत, संजय राउत, सुनील राउत, इन्होंने जो महिलाओं के बारे में जो अपशब्द कहे, एक लफ्ज से उद्धव ठाकरे जी ने उस पर बयान नहीं दिया है, ना ही उनका इस्तीफा लिया है। अरविंद सावंत महिला को माल कहते हैं, संजय राउत तो मुंह खोलते ही गटर की दुर्गंधी आती है, और सुनील राउत हमारी कैंडिडेट को बकरी कहते हैं। तो आपको अभी बकरी पसंद है, क्योंकि आप जिनके साथ उठते बैठते हो आज दिन रात, तो वो इसी प्रकार की बातें आप करेंगे, और नई बात क्या करेंगे। मगर ठीक है, संजय राउत और सुनील राउत ये किसी दुर्योधन दुशासन से कम नहीं है। ये दुर्योधन दुशासन है, महाभारत के अंत में उनका जो हाल हुआ था वैसा ही हाल इन दोनों का होने वाला है। यहाँ महिलाओं का मान सम्मान करते हैं, और वो वहां पर वस्त्रहरण करते हैं महिलाओं का। ये संजय राउत और सुनील राउत ये महाराष्ट्र के उद्धव ठाकरे पार्टी के दुर्योधन और दुशासन है, और उनका वही हाल होगा, और हमारी लाडली बहना इनका हाल करेंगे। बघा, कोणतीही श्रेयवादाची स्पर्धा नाही आहे। आत्ताची जी योजना आहे, जी पुढे कंटिन्यू होणार आहे, ती मुख्यमंत्री माझी लाडकी बहीण आहे। आता कोणी तो शब्द वापरो अगर न वापरो, शेवटी त्या महिलांना निधी मिळाला पाहिजे, गरीब होतकरू गरजू महिलांना तो निधी मिळाला पाहिजे, आणि
आम्ही ते शब्दच्छल करण्यापेक्षा महिलांना तो निधी मिळाला पाहिजे याच्यावर आमचं भार आहे.
माहितीची जागा होती त्यावरून मुख्यमंत्र्यांनी का वृत्तपत्राला दिलेल्या मुलाखतीतून अनेक गोष्टी क्लिअर झालेल्या आहेत. भांडूपसाठी खरं तर जागा मनसेची अमित ठाकरेंना सोडण्याच्या संदर्भात चर्चा झाली होती का, आणि त्या संदर्भात नंतर राज ठाकरेंनी सदा सोबतकर यांना देखील भेट नाकारली. कुठेतरी हा मुद्दा पुन्हा एकदा प्रकाशात येतो आणि राज ठाकरे हे ज्या पद्धतीने मुख्यमंत्र्यांवरती टीका करत आहेत तसं पाहतो.
राज ठाकरे मला त्याच्यावर खरं जर जास्ती बोलायचं नाही आहे. ते कधी कुठली भूमिका घेतात, कधी काय घेतात. त्यांनी आता हे वक्तव्य केलं त्यात कुठल्या वेळेला केलं, सकाळी केलं का संध्याकाळी केलं, परंतु एवढंच मी सांगू शकते की राज ठाकरे यांना खरं आम्ही व्यवस्थित राईट टर्न दाखवला होता, पण त्यांनीच रॉंग टर्न घेतला. आता आम्ही काय करणार. नाही बघा, त्यांची नाही असं आहे की आमचे विचार क्लिअर आहेत. आम्ही हे एक नाही तर अनेक वेळा सांगितलेलं, आमच्या प्रवक्त्यांनी सांगितलंय की नवाब मलिक यांचा प्रचार आम्ही करणार आहे. दॅट्स ऑल. नाही ठीक आहे ना, त्यांनी त्यांची उमेदवारी जाहीर केलेली आहे. त्यांचे काहीतरी पॉलिटिकल कंपल्शन असेल, त्यांनी केलं, परंतु आम्ही काय करायचं ते आम्ही ठरवू शकतो. एक मिनिट मी काल महाविकास आघाडी सरकारच्या पंचसूत्रीमध्ये माननीय उद्धव ठाकरे यांनी असं म्हटलेलं आहे की आम्ही प्रत्येक जिल्ह्यामध्ये छत्रपती शिवरायांचं मंदिर उभारू. अहो, तुमचे खासदार आमदार महिलांचा सरासर अपमान करतात, गलिच्छ भाषेत बोलतात, त्यांचा पाणउतारा करतात. अरविंद सावंत असो, संजय राऊत असो, सुनील राऊत, आता हे दोघं भावंड आहेत, संजय राऊत, सुनील राऊत. आता दोघांच्या काल तुम्ही बघितलं की सुवर्णाताई करंजे यांच्याबद्दल बकरी शब्द त्यांनी वापरला आणि 23 तारखेला बकरी कापणार. हे उद्धव ठाकरे यांच्या पक्षातले दुर्योधन आणि दुःशासन आहे, संजय राऊत आणि सुनील राऊत. आणि महाभारतामध्ये या दोघांचे काय हाल झाले, या दुर्योधन दुःशासनाचे, ते आपल्याला माहित आहे. तेच हाल त्यांचे होणार आहे. धन्यवाद.
All right, so let us now go into the details of this protocol. After having had a look at that initial demo, let's see a little more, let's understand a little more things about MQTT before we actually do further demonstrations to understand this protocol better. Alright, so let us start with the standard publish subscribe, because this is based on the publish subscribe architecture. Let me put back the broker. This is the broker, and there are what are known as publishers, and there are subscribers, right? Subscribers. Right. So, so this basic idea here is that you can actually, when you say broker, yesterday we saw this thing related to Hive MQ, right. There are other open source brokers as well. There is something called Mosquitto, and you can install Mosquitto broker for all your tests on Ubuntu machines. Simply in fact it is available for Ubuntu, Linux, Ubuntu, it is available for Windows and so on and so forth. So, you can actually install your own broker. It is open source, mind you, it is open source. So, really you can take and manipulate it the way you like. So, install the open source broker on any host that you like, and you can install the client software which is called PAHO, PAHO, also available as open source. Okay. So, you can install PAHO for all MQTT clients. These are all clients as we call it, and you can actually build this complete system on embedded devices. For instance, this broker can run on Raspberry Pi, okay, and the PAHO being an open source client, you can attempt to put them on embedded devices as well, provided there is TCP/IP stack, right, because this MQTT actually runs as an application protocol in the application layer, and it uses TCP for all its transport requirements. This is a simple thing. Now, take a simple case of publishing, let us say, some value, let us say presence, right, motion. You want to publish a topic basically, and the topic is motion, because yesterday we took the example also of motion when we showed, and you say motion detect, right, we said detect. It can also be a value, right, it can be a number, but I just took it for simplicity and will continue taking this as a nice example. And now the broker is expected to keep it with it and give it to all subscribers who subscribe to this particular topic. Okay, the topic name is motion. Now, as I mentioned to you, there is complete decoupling of publisher and subscribers. There is no connection. Publishers and subscribers. This is a very important point. So, there is nothing like a end-to-end connection, and in fact subscribers do not know who the publishers were and where they are situated, where they are located and so on. It is the responsibility of the broker to ensure that all nodes that basically request for data to which subscribe to that particular topic are actually served that data. That is the key point. Now, whether the broker should hold the data if there are no subscribers is one question that will come to your mind. Another thing that comes to your mind is what happens if the subscriber goes offline. Okay, so cases like no subscribers, what should happen, and what happens if there are subscribers but subscribers go offline, right? Both possibilities exist. Subscribers go offline. So such situations have to be handled, and the protocol is well suited for taking care of this situation. Well, as far as no subscribers are concerned, the point really, the beauty of this protocol is such that no publisher need to announce the name of the topic a priori. There is no need at all. In other words, I can simply start a new topic and then start publishing the data to the broker. If I know the IP address of the broker, if I know the name of the broker, I can start publishing it. You can start arbitrarily with something. In fact, yesterday's demo was also like that. We just took something, I punched in a few name of a topic name, and then put some value to it, detect, not detected, and so on, and just pushed it to just published it to the broker. So the very fact that brokers are accepting it without any a prior information about what the topic is clearly, it doesn't make any assumptions that there are going to be subscribers. Now you can actually implement this in a very scalable manner, and you can perhaps wait for a certain interval of time. You can configure HiveMQ or Mosquitto particularly. You can configure these open source tools such a way that after a certain time, if there are no subscribers, you simply purge that information. You just remove it because there are no subscribers. That is one policy you can take. Another policy you can take is, I don't want to get into that. I will just go on archiving whatever messages that come, irrespective of whether there are subscribers or not, is another way by which you may want to do it. So you can go on archiving all the messages which are published by different clients and keep holding it onto a database. That is also a possibility. It may turn out that at some point in time, no subscriber actually turns up, right, for that particular topic, in which case it just gets archived, gets stored if you configure it that way. Alright, so lot of flexibility exists, and you have to actually plan everything, both your configuration of the broker as well as configuration of the client based on your requirements. Okay, so that's the key point that comes up very strongly. So is this a scalable solution? People have asked this question in different ways. Community which supports this particular protocol and loves this protocol actually claim that it is a very scalability is actually there, and one of the things that they say it is scalable because of the fact that publishers and subscribers are decoupled. So one of the main attractions for this particular protocol to succeed is because the fact that there is no need to keep state information, no need to lock up a lot of memory resources between multiple clients and multiple servers. You don't need to do that. All your business as a broker is to just accept messages and store or purge based on certain policies that you set. Also store or purge messages based on certain flags which you will energize when you send packets. Okay, so it could be based on either a policy or based on certain flags which you will we will see as we go along, and this is a very important thing. So people do say that this is a very scalable thing exactly for that. So the second reason is that I am not too sure whether it will go to millions of connections, whether it will take to that is not sure. I don't know whether any large scale such implementations have actually happened, but definitely it appears that this is a scalable system. Okay, another thing that comes in favor of this MQTT indeed is the fact that filtering is a very nice thing in the broker. Okay, filtering, in other words, you can do filtering based on subjects, you can do based on subject based filtering, you can do content based filtering, and you can also do some type based filtering. Okay, I will not get into the details of this filtering, but the point really is, if you have topics and topics which are indented one after the other, you can basically have clients asking for a very specific topic of requirement. You can do that, and when we discuss when we see demonstrations of the wildcard options, you will actually see that clients can actually ask for very specific information, and broker actually can do that, can give you exact information. okay, and it say, okay, you didn't ask for this, I'll not give you this. You have subscribed to this, but you are asking me for a specific information, that is also possible. Okay, so it is able to intelligently sort messages out, filter messages out, and just serve whatever was requested by the subscribers. That is a beauty really, and I think it works very well. Small networks, you want to get going quickly, you have a set of IoT devices, you want to get them to transmit data, and have a simple broker up and running. Go and install MQTT on a Raspberry Pi, go and install MQTT Mosquito on a Raspberry Pi, or for a broker on a Raspberry Pi or on a regular laptop, and have PAHO running on embedded devices to start communicating. So that's the second reason. So these are two important reasons that it seem to have. It isn't that these are the only two things about MQTT. There are some very nice things which come back to you with respect to quality of service. Essentially, MQTT says I can give you 3 levels of quality of service. I can give you something called at most once, then at least once, and exactly once, right? Once. So these are the 3 possibilities. Simply means, the first one simply means that this is best effort. Okay, this is best effort. And the second one simply means, yes, you will definitely get one or more, guaranteed, one or more. Exactly once means, obviously as the name indicates, only one. Application always gets only one. This is the nice thing about MQTT, so it is able to do all of this. See, the question really that might keep bothering you again is, if you look at the OSI model, TCP is at the transport layer, okay, then you have session, and then you have the application layer. The application layer really has the MQTT, right, which is using the services of TCP. It actually can also use UDP, but traditionally it has been using TCP. You can say that when TCP is a reliable protocol by itself, which relies on unreliable protocol like IP, where best effort is the main thing, why would you want to have these kind of QoS system, QoS requirements at all? Because anyway it is going to use TCP. Well, the answer is very debatable, but people do talk about this is still at the transport layer. It is not going to give you what the application that is designed around MQTT. So if you want at higher layer, you want reliability, you may have to introduce this kind of a quality of service requirement. So that's a major question that they the reason why MQTT QoS is actually present. Okay, so there are some nice things about the MQTT. When people talk about it, people talk about the client, and they talk about so when they say a client essentially is it can be any device, right? So just quickly to run through, it can be any device, from a microcontroller to a base system to any sophisticated machine. It could also be a full-fledged server and so on, which has a network connection. Okay, so that's the key here. You need a network connection. So any device having a microcontroller, then TCP/IP stack running, then MQTT, of course. MQTT is the application layer protocol. So MQTT client means MQTT software running on this microcontroller system. There is TCP/IP stack, then there is the network stack. Of course, there is network. Of course, when you say TCP/IP stack, you obviously know that there is the so let me just combine it. TCP/IP protocol stack plus there is a network to run this protocol stack. So this is all what they talk about a client. Then you say MQTT broker. broker also is any device. It could be typically like a server which has a lot of ability to store messages. So essentially it has to be a sort of a server grade machine essentially which is able to receive messages. It is able to receive messages, it is able to filter them, okay, store them, filter them, and serve messages, okay, or serve messages to subscribers. So all these actions it has to do. It has to be obviously depend, because it supports, the whole system supports these quality of service levels. The server has to be a highly reliable one, highly reliable, right. This is the requirement of the hardware, and it is easy to monitor, of course, and it should be failure resistant and so on and so forth. So when you say highly reliable, you actually mean it should be failure resistant. So the whole operation starts by a certain set of what shall I say, essentially messages, right. When you say a protocol, you essentially talk about messages, and there are several messages in MQTT. One of the important messages that you can think of is connect. Before you do any publish or subscribe, you do connect, and in response to connect. So where does this connect work? Connect works from the client to broker. I am very careful when I say client to broker. A client essentially is either a publisher or a subscriber, right, either a publisher or a / subscriber, right, and there is a broker here. So it starts with a message called connect, for which the broker will actually issue back connection acknowledgement, also called CONNAC. So connect CONNECT, connect gives you back CONNAC, CONNACK, CONNAC, right. So this is what would happen as a first step, and the good thing is, if this is actually done as a first step before you do any publish, subscribe or anything, it clearly indicates that this can actually pierce through network address translation kind of firewalls. So if you ask a question, does MQTT work over firewalls? Yes, the answer is yes, because the MQTT broker and the client basically establish the first level, which is essentially initiation happening through connect and CONNAC, and therefore it is quite easy that MQTT clients can actually be behind routers which essentially can run firewall applications. So that is a good thing. So when you say connect will have a certain set of what shall I say, fields, right. So a very interesting set of fields. A connect will have a client ID, and it will have something called a clean session, okay. It will have something called clean session, I will explain that in a moment. Username, then there will be a password, then there is something called last will topic, and last will message, and last will retain, right. So all, and of course there is something called keep alive. So essentially the client ID is basically a identifier of each MQTT client that connects. When I say client, it could mean both, either the, not both, it could be either the subscriber or the publisher. So we generalize and say it's a client. Clean session is an interesting option. See, we did discuss here about the fact that message should be stored on the broker if there is a publisher who publishes the data, or it should be removed, right? Because when you start publishing, you are not actually indicating the name of the topic at all. So, but if you want to ensure that the broker actually has to retain that message on itself, then you use this session ID accordingly. You say that I want to create a session and I want to ensure that whatever messages that come using this session actually are retained on the broker. Okay. So that is something that you could do right at the beginning by using this particular field of a connect message. You could also do, so you essentially set clean session equal to false. Okay, if you set it to false, then actually that message is stored on the broker. But indeed, if you set it equal to true, that message goes, and if there is no takers on that, it is possible that that message may get removed. However, there are what are known as QoS levels. Okay, so this is in a way also connected to the QoS levels, but when we come to that, you will see that it's interesting. Okay, let me connect the whole thing. If you say, for instance, clean session equal to is equal to true, okay, and your QoS level is 0. Okay, there, so essentially when I say QoS level is 0, at most once is actually 0, at least once is 1, and exactly once is 2, right? These are the 3 levels. Now let us go back and put it here. If clean session is equal to true, okay, and QoS level is equal to 0, definitely the broker will not hold the data, right? Then so that is one thing. Now the other thing is, if clean session is equal to false, that means you want to keep the system, you want to keep the message on the broker, then so you make it false, then this essentially it will become a persistent session. It becomes a persistent session. Again, it is interesting to see what would happen if QoS is 0, QoS is equal to 1 and 2. So when we do these exercises, we will perhaps be able to have a look at it, right. So that is one thing we will take as we go along when we do the experiments using these laptops, using the laptop. So then there is username and password. This is purely from an authentication perspective. Last will and last will topic and last will messages are interesting again in the MQTT paradigm, because MQTT allows ungraceful shutdown of clients. Okay. So in other words, if you take energy harvesting based systems, right, energy harvesting based nodes which are trying to sense data and use MQTT for publishing their messages, publishing their sensed value, it's possible that they are not harvesting anymore. They may actually shut down very quickly, and that shutdown can be very ungraceful. In such situations, it is very easily possible that the client actually gives a last will message saying that this is the last, I am going down, and therefore take this as my last will and testament, and use this for all, this is the last sensor value that I can actually provide under this topic. So the last will topic name is there, then there is a last will message which is essentially the value that you want to put are all there. That is something that you can actually do right